All right, for our math warm-up today, I'd like you to go ahead and number your board or your paper from 1 to 4. Look at each set of numbers or decimals or fractions. As you can see, there are some of those. And determine what is the rule. So our rule for 1, 5, 9, and 13 is to add 4. Our rule for 2, 4, 8, 16, and 32 is to multiply by 2. Our rule for 1 and 5 tenths, 2, 2 and 5 tenths, and 3 is to add 5 tenths. And our rule for the last one with 8 eighths, 7 eighths, 6 eighths, 5 eighths is to subtract 1/8. How did you do? For our math message today, I would like for you to take a look at this in and out table that I have down here in the bottom right. And I want you to think about what rule could you use to find the next number in this pattern. So we have 1, 2, 3, 4, 5. We're trying to come up with a rule for finding this side of our n table. So what might you do there? Go ahead, pause your video, write your answer to that question. Then we're going to look at the second question. What rule could you use to find the next number in this pattern? We have 2, 4, 6, 8, and then 10, which happens to be the numbers here on the outside of our in and out table. Go ahead and write your answer. Pause your video if you need to. And then here is our combination question. What rule relates the in and out numbers in the table? So that means, can you come up with one rule that's going to relate both of those? It's going to cover everything. All right, so if we go back to question A, which rule could you use for the 1, 2, 3, 4, 5? Most of you probably figured out or wrote down that we would add 1. And how do we know this? The numbers are going up by 1, so we can just add 1 to get the next number. Now, if we look at the second question, or question B, we could say that the rule was add 2. And how do we know this? Each number is 2 more than the previous number. So when we looked at the 2, 4 is 2 more than 2 above, 6 is 2 more than 4 above, 8 is 2 more than 6 above, and 10 is 2 more than the 8 above. So this list of numbers that we have and what we're going to call this side part A and this side part B is they are called sequences. And you might not have heard them related or used that term before. But sequences often have an underlying rule that is used to generate the numbers in the sequence. And sometimes the sequence is also called terms. So for example, 1, 2, 3, 4, and 5, and so on are the terms of the sequence from part A. In the past, when we've done in and out boxes, we have focused on the relationship between the in numbers and the out numbers. So what is the rule that relates the in numbers and the out numbers, which was our last question here? We could say that that rule was double, or we could say it was times 2. And that could be the relationship between those two numbers. Now, the difference between the two kinds of rules is that the sequences are used to generate a list of numbers. The rules that describe the in and out relationship are used to find an out number and goes with a given n number. I know that sounds a little bit confusing, but hopefully it will start to make more sense as we dive deeper into this lesson. Now, what do you notice about the numbers in the n column? They go up by 1, which we said previously. So all of those go up by 1. What do you notice about the numbers in the out column? They go up by 2, and they are the numbers from part B. So the terms of the sequence from part A and B have been matched up in this in and out table so that the first term from each sequence is in the first row. The second term from each sequence is in the second row, and so on. These pairs of terms, meaning this one and this one, or this one and this one, are called corresponding terms of the two sequences. So each row of the table shows a pair of corresponding terms. So our lesson today is identifying and visualizing patterns. We are doing this lesson today because we need to look for and create rules used to generate number sequences. And we're going to take a more in-depth look at in and out tables that we've used in the past. How we're going to do this is we're going to graph ordered pairs made from corresponding terms of sequences, and we're going to use the graphs to help us visualize the patterns and relationships between the numbers. All right, so let's do some practice with what this whole lesson is about. So I have an in and out table, but you'll notice that my in and out table has a rule on each side. So my rule is +2 for this side and +4 for this side. So if I take 0 plus 2, I'm going to get 2. 2 plus 2 gives me 4. 4 plus 2 gives me 6. 6 plus 2 gives me 8. And on this side, if I have 0 and I add 4, I get 4. 4 plus 4 is 8. 8 plus 4 is 12. And 12 plus 4 is 16. Now remember, these are corresponding values, okay? So we're going to come up with an in and out rule that's going to get us from this side to this side. So I came up with times 2. So if I take 2 times 2, I get 4. If I take 4 times 2, I get 8. 6 times 2 gives me 12, and 8 times 2 gives me 16. I then take these in and out values and I transfer them and make them my ordered pairs. So once I have my ordered pairs, and I did not put 0 and 0 in here, that's why we have one that's blank, I then came over to my graph to place those. Now, it was really hard to place these dots on these teeny tiny little squares using a stylus, so they are a little bit off. But with your workbook pages, you should be more accurate. So the first one, we're going to go over to up 4, make a dot, and as you can see, my dot's a little off there. We go over 4, up to 8, over 6, up to 12, and over 8, up to 16. So the next step is to actually connect those dots with a straight edge, and if we had had our 0 and 0, it would be there. And so we connect all of those dots with a straight edge, and we place an arrow on that line to show that it goes infinitely in both directions. And so that's going to help us answer questions later on about this information. So even though I don't have the next ordered pair, I could answer a question that said, what would 10 be, right? So if I'm looking at, if I go over 10 and up to what number would it be? It would be 20. So I could see from this line that 20 is going to be the next one, and then I could keep traveling up that line to answer the question to continue that data set if I needed to. So most important thing to remember is these values are corresponding. They end up becoming your ordered pairs. Your ordered pairs then get plotted here, and then we always connect those dots to show that that data continues on in both directions because it is a line. And that's about it for this. So let's summarize what we've talked about. The list of numbers in parts A and B are sequences and usually have an underlying rule that is used to generate the numbers in the sequence. The pairs of terms in each row are corresponding terms or values, as I stated earlier. For example, 3 corresponds to 6 in that original table that we did. And we can graph the ordered pairs to visualize the patterns they make. Hang in there. You've got it. See you in class.